Okay, so today we're going to start Chapter 5, Section 1, and we're going to be, today, there's a lot of notes in this. There's actually 21 slides, but again, I'm going to break it up over several days. So today we're just going to look at exponential functions and their graphs. So an exponential function, in this, the exponential function f has a base of a, and it's going to be written as f of x equals a, which is the base, raised to that power of x. And in our functions, the variable is going to be that exponent or that power. So the base is going to be a number. So for example, we will be graphing functions where the base is greater than 1. It can't equal 1. And then we'll also be doing some fraction bases, but for now we're just going to focus on bases that are greater than 1. So for example, we might do a function like 2 to the x power or 3 to the x power. We're also going to see the variable e, which is going to be like pi when you did geometry. It's actually got a value to it. E is approximately equal, just like pi was approximately equal to 3.14, we're going to see that E is approximately equal to 2.71. And there's actually a button on your calculator. They use E in a lot of, I guess, money formulas. All right, so let's go ahead and take a look at the general shape of an exponential function. So over here, when your base is greater than 1, the graph on the left is the general shape that the graph will take. When your base is a fraction, then the graph will go in this shape. It'll be falling from the left to right. These are the general shapes that the graph of the exponential function is going to take on. Now, they're all going to be having this order pair of 0, 1. Now, unless the graph is shifted. So they'll all have that order pair 0, 1 when there's nothing added or subtracted to the base or added or subtracted to that exponent. So what we're going to be doing here is we're going to be using a t-chart to graph our functions. Now, the domain for these exponential functions is going to be all real numbers. What I'm talking about a t-chart is I'm just going to make a little t here, and then I'll put x's that I'm going to plug in, and then I would write whatever the function is over here, and then get my values. So let's go ahead and try to do this. And let's make a t-chart, and then we're going to graph the order pairs that we get. Let's go ahead and try the first function. It's 2 to the x power. So in order to graph this, since I'm not using my graphing calculator, I'm going to make my little chart here. Now remember, this f of x, this is a fancy way of saying y equals 2 to the x power. So really what I'm doing here is I'm saying y equals, and the answer I get when I plug it in goes under this column. Now, you can choose whatever values of x you want. I always try to plug in negative numbers, plug in a 0, and then also plug in positive numbers. Now, for this first one, I'm going to do a bunch of numbers. But when you're graphing these, I only want to see you do it 3 times. Now, in the web assign tonight, it's going to say when x equals 1, what does the function equal? So all you're doing is plugging in numbers and simplifying this exponential function. So let me go ahead and I'm going to plug in -3 for the x. So I'm doing 2 to the -3 power. Remember, when you have a negative power, it doesn't make the number negative, it turns it into a fraction, or think reciprocal. So this really becomes 1 over 2 to the 3rd, and then I get 1/8. So the order pair that I'm going to graph is going to be the order pair -3 and then 1/8. Now, these are going to be kind of hard when they're fractions and my graph goes by ones. But again, I just want to see the general shape and then throw in at least 3 points. So let's plug in -2. This first time I'm going to do a bunch of points. But again, when you're doing it, all I want to see is you do 3 points. So -2, I'm going to plug it in. Goes up here for the x. Again, negative exponent, put it underneath a 1, evaluate it, 1/4. If I plug in -1, and this is what you're doing in the homework on some of the questions, just plugging in whatever they tell you to plug in. 2 to the -1, again, makes it a fraction, so it's 1/2. 2 to the 0 power, anything to the 0 power equals 1. Remember on the previous slide, I showed you that all of those exponentials, they all had this ordered pair, 0, 1. Because anything to the 0 power is 1, as long as there's no shifts involved. Then if I plug in +1, 2 to the first power is +2. If I plug in 2, 2 squared is 4. If I plug in 3, 2 to the third power is 8, and so on. And I could keep doing this and get a whole bunch of ordered pairs. Now, notice as my x's are increasing slowly, they're slowly going to infinity. However, my y values are getting to infinity a lot faster. So these are all approaching infinity. So let me go ahead and graph these ordered pairs now. So again, if I put on here, let me put like some of the whole numbers here, it'll be easier to see. So if I graph the ordered pair, 0, 1, and then 1, 2, and then 2, 4, and then 3, 8, and then over here, if I go on the other side, the -1 and the 1/2, well, that's like right here. Now, these exponential functions have a horizontal asymptote of the x-axis. So my horizontal asymptote here for my exponential functions, and let's see, it's in blue, is going to be y equals 0. This is my horizontal asymptote. My graph is not going to cross that. So notice how my negative numbers here that I plugged in, it's slowly getting closer and closer, but it's never going to go below it. It's just going to skim along there. And then it would go up to the top there. So that is the graph of 2 to the x power. Now, when it's 3 to the x power, it's going to go up a little bit faster, but it's still going to take on that same general shape. Now, I know I plugged in a bunch for the first one. I'm not going to do nearly that many. So again, for number 2, do my little chart here. And it's y equals 3 to the x. So I'm going to plug in, I'm actually going to plug in 5. But again, what you should be plugging in when you're doing this, 3 points. I would plug in a negative number, 0, and a positive number. And then just add in the general shape. So for this one, I'm going to do 5, just because we're just now still learning. So 3 to the -2 power. Remember again, it doesn't make it negative. It makes it go underneath the 1. And this becomes 1/9. Then -1 when I plug it in, this becomes 1 over 3 to the first, which is just 1/3. When I plug in 0, anything raised to the 0 power equals 1. When I plug in +1, this gives me 3. When I plug in 2, 3 squared is 9. So notice it's going up a little bit faster. So let's go ahead and graph some of these. So again, I can put on -2 and 1/9, so really close there and there. And then it's got the 0, 1 that they're all going to have. Then it's got the 1, 3, and then the 2, 9. way up here. So again, it's got this horizontal asymptote here. So again, the graph is going to skim along that, and then it's going to sweep up. Again, you only need to put the order pair 0, 1, and then 2 other order pairs. You don't need to do a whole bunch. If you choose to, you can, but it's not required. So notice they're all taking on this same shape when this base is a number that's greater than 1. It's not a fraction. Let's try another one. Same thing, it's just going to go up super fast because my base is now going to be a 10. So again, I'm just going to do my little chart. This time I'm going to do only 4 order pairs. So again, I'm doing y equals 10 to the x. I'm going to plug in -1. 10 to the -1 power is 1/10. I'm going to plug in 0. Anything to the 0 power is 1. I'm going to plug in 1. 10 to the first is 10. And when I plug in 2, which obviously I'm not going to be graphing, 10 squared is 100. So again, I can go ahead and graph. Again, I've got my horizontal asymptote, which is y equals 0. I'm going to plug in -1 and 1/10, which I can say is about here. Oops, I don't want highlight. And put it here. And then I'll put the 0 positive 1, the 1/10, way up here. And again, you see how it's going up super fast. It's jumping from the 1 all the way up here to the 10. So this one went super fast. Now we're going to do a fraction when the base is a fraction. So again, let's just do our little chart. Get some order pairs. X, and then y equals 1/2 to the x. So I'm going to plug in -2. So 1/2 to the -2 power. Remember, when a fraction is raised to a negative exponent, think reciprocal. Flip the fraction upside down, make it 2/1, and then make the power positive. So then this just becomes 4. Then if I plug in -1, 1/2 to the -1 power, again, think reciprocal, then make the power positive. So this is just 2. Then when I plug in 0, anything to the 0 power equals 1. When I plug in positive 1, 1/2 to the first power is just 1/2. And then when I plug in 2, 1/2 to the second power is 1/4. So when the base is a fraction, our graph is going to flip. It's going to be up on the left side, and then it's going to go down on the right side. So let's go ahead and graph these order pairs. So I have -2, +4. I've got -1, +2, the 0 and the 1, and now it's sweeping down this way. And again, it's still got this horizontal asymptote of y equals 0. And again, if you connect your points, you can see it's sweeping down. It's flipped versus the one where the base is 1 or bigger or greater than 1. The base can never be 1. Let's try another fraction. So again, same thing. I'm only going to do 3 this time because that's all I'm going to expect from you. So x, and then y equals 1/4 to the x. And again, if you'd want to do more, you can. Now remember, when you're doing this, you can key these into your calculator and check your answers. Now, I'm going to show you how, remember yesterday I was telling you, or the day before, that when you're keying in the rational functions to put parentheses around the numerator and the denominator, you can also, when you hit that y equals button, key it in as a fraction. And I'll show you how to do that as well. But know that you don't have to put parentheses and use the division. You can actually input things as fractions. And I can show you the different ways to do that. So again, I'm going to plug in -1. Again, think reciprocal. Flip it. So this equals 4. Then when I plug in 0, 1/4 to the 0 power is 1. And then when I plug in 1, I just get 1/4. So again, you're memorizing the general shape. You'll draw your asymptote. So I'm going to graph these 3 ordered pairs. -1, +4. And 0, 1. And then the 1 and the 1/4. Again, in the general vicinity here. Again, it's skimming along the asymptote. Now, at the beginning of the notes, I told you that I was going to introduce you to the number e. E is not a variable here. E is a number. Just like pi is a number, e is approximately, if you hit e on your calculator, it's a crazy long irrational number, and we're going to approximate it to 2.71. Just like we use 3.14 for pi, we're going to use 2.71 for e. So let's go ahead, and if you are rounding, since our graphs are going by ones, you could think of this as being approximately 3. So when we go to graph, you know it's got to be close to the 3. But let's go ahead and plug in our numbers and do our t-chart. So I'm going to plug in -1. So y equals e to the x. So what I'm really doing here is e to the -1, which is really 2.71 to the -1, which is really 1 over 2.71. Does that make sense? So then if I divide that, 1 divided by 3, it's about 1/3. If you want to think about it that way, it's actually approximately equal to 0.369, and it keeps going. So again, around 1/3 when we go to graph this. And then if I plug in 0, e to the 0 power, well, doesn't matter if it's e's a decimal, anything to the 0 power equals 1. And then when I plug in +1, e to the first is just 2.71. So when I go to graph, I'm going to be putting my points close to 3. So when I go to graph this one, the -1, and then the 1/3, so about there, and then really close to the 3. And again, draw in your horizontal asymptote, and then connect your points. So again, just approximate e to be about 2.71, which is really close to 3. So really what we're doing is almost graphing 3 to the x here, because 2.71 is about 3. Now, you may see instructions that will say to truncate an answer. If you ever see that, for example, on a calculator, if I were to divide, let's see. So if I divide this fraction, 5/7, the decimal I get on my calculator is this. If it said round to the 10th place, this answer would be 0.7. But if it said truncate, then let's say it said truncate to the 100th place. Truncate to the hundredths. What this means is anything that's after the hundreds place, chop it off. So truncate means just chop off. If it says round, remember that's when you look at the number next to it. If it's 5 or bigger, it goes up. If it's 4 or less, it stays the same. But when it says truncate, whatever place value they say to truncate to, chop it off. So if it said truncate to the tens place, then it's the same as rounding on this one. For example, let's say it said truncate to the tenths, and let's say the decimal was 0.75. So if it says truncate, then this answer is 0.7. But if it says round to the tenths, then it becomes 0.8. Everybody see the difference? So be aware of this terminology. A lot of times what they'll do is they use the word truncate when you take the AP calculus classes. All right, everybody good on example 6? All right, so now what we're going to do is talk about shifting our graph. Now, when we shift our graph up and down, in addition to shifting the graph, we're also going to shift our asymptote. If we're shifting it left and right, the asymptote isn't going to move. So let's go ahead and see the different shifts. So for this one, whenever there is a negative sign in the exponent here, this is going to be telling me it's going to be a reflection across the y-axis. If the negative sign is in front of the base, so in front of the base, then it's going to be a reflection over x. Across the x-axis. So when it's in the exponent, we reflect it across the y-axis. When it's a negative sign in front of the base, then it's going to be a reflection across the x-axis. Now, for this one, we can go ahead and just do the t-chart and plug in our numbers. However, if you wanted to graph the basic function and then reflect it, you can do that as well. But for these that are this simple, I'm just going to do another t-chart and plug in the numbers. So let me go ahead and do a chart for this function. Y equals 2 to the negative x. I'm just going to plug in 3 numbers, -1, 0, and 1. So when I go to do this, be very careful. It's 2, and then the negative sign is there. But then I'm putting the -1 in for the x. Negative here on the power becomes positive, so then this becomes just a 2. When I plug in a 0, it's not a -0, no such thing, so it's just 2 to the 0, and that's a 1. And if I plug in +1, 2 to the -1, then that's the fraction. So let's go ahead and graph these 3 ordered pairs. My asymptote, I did not shift my graph up or down. So my asymptote is still here. And then if I graph -1, +2, 0, 1, and then 1, ½ And again, make your little sweep here. Have him skim along the asymptote, and there's your graph. Notice the normal f of x to the 2x would have gone the other way. And you can see how it was reflected. Remember, this one swept this way. And you can see how they flipped it and reflected it. All right, next one. We're going to reflect it across the x-axis. And again, I'm just going to do my little chart here. Y equals -3 raised to the x. Plug in the same numbers, yes.
Wait, isn't it the same as a fraction?
Same, yes. Okay, so that's a good point. So this is actually the same graph as the f of x equals 1/2 to the x. These are actually identical. Everybody good on that? Because if you think about it, negative power flips it to reciprocal. Yes, thank you. Good point. All right, so then this one, if I plug in numbers, let me plug in -1. So -3 raised to the -1. Notice there's no parentheses. So really, all this -1 is on is this 3. And then the negative sign is going to fall in front of my answer. So this is -1/3. Then if I do and plug in a 0, -3 to the 0 power. Be careful on this one. The only thing that the 0 power is the 3, and then the negative goes in front. So this becomes -1. So be careful when there's a negative sign in front of the base. And if I plug in +1, -3 to the first becomes -3. You know, even if you plugged in 2, -3 squared, this is -9. Because again, the power is only on the 3 and the negative goes in front. All right, so let's graph these ordered pairs. So again, I still have my horizontal asymptote here, but now it's flipped. So I'm graphing -1, -1/3, which could be right about there, and then 0, -1, +1, -3. Oops. And then +2, -9. And then it'll skim. So this one has been reflected across the x-axis. So they flipped it down. The next slide has a nice little summary of all the rules for the transformations. So for this one, so when it's vertical translation, this means that you're shifting your graph up and down. Now, when you shift your graph up and down, we also have to shift the asymptote up and down. So if it has +2, that means that we're going to move it up 2 units, and you would also move your asymptote up. So when you're adding a number, it's going up. So adding a constant is moving your graph upward. Subtracting a number from that exponent would be shifting it down. For the horizontal translation, this is going to be left and right. Now, when it's a left and right translation, we don't move the asymptote. Now, this time, the left and right shift is something that's being added and subtracted in the exponent. So when something is added to, and this is backwards of what you think. So when you add something, you would think you're moving to the right, but it's backwards. So when we add something into that exponent, we're moving it left. When we subtract something, we're moving it to the right. And then we just saw the 2 reflections. So again, when the negative is in front of the base, reflect across x. When the negative sign is in the exponent, it's a reflection across y. And then these other 2 down here, the vertical stretch and shrink. So again, when your base is greater than 1, then it's going to stretch it. It's going to go up faster. And then when your base is a fraction, then it's going to shrink the graph. Or I'm sorry, when there's a number in front of that, it's going to be, when it's a fraction, it's going to shrink the graph. And then here, the horizontal stretch, this is when your C value here, up here, the number you're multiplying your power by, if it's greater than 1, it shrinks it. If it's a fraction, it's going to stretch it. And again, think about shrinking it as like making it wider or fatter, and then the stretch is going to be like making it long, go up faster and skinnier. So let's try some of these shifts. So let's identify the transformations, and you're going to do this in the homework as well. So over here, what I've got here is this subtract 2. So when it's being subtracted to the base, you think of it as being outside or away from it. This is the vertical transformation. And this is going to be just what you think. It's subtracting the 2, so we're going to be moving it 2 down, 2 units down. So for the up and down translation, it's not backwards. It's whatever you think logically. So that would be that shift. And let's go ahead, and what my advice to you is, just like we did before with the other parent functions, what'll probably be easier is if you do the t-chart for just the x to the 3 to the x power, and then shift all the points 2 units down. If you want to plug in numbers into the whole original function, that's up to you, but it would be a lot easier if you just plug in -1, 0, and 1, and then shift all the points 2 units down. So 3 to the -1 is 1/3. 3 to the 0 is 1. And then 3 to the first is 3. So let me graph these original ones. Now, here is my original asymptote. Right now, my original is at y = 0. Then I'm going to graph the original in blue as well. So I have -1, and then the 1/3, the 0, 1, and then the 1, 3. So this is the original graph. And then when I now take these 3 points and shift them 2 down, I also have to shift the asymptote 2 down. So now my new asymptote is now here at y = -2. So this is the asymptote. And now I can graph and move these points all down 2 units. And then just do the sweep. Now you can plug in these same numbers or whatever numbers you want for x all into the original function. But again, it's a lot easier just to go ahead and plug them into just the basic function there. And then from there, go ahead and just shift it. Let's try the next one and see where the shifts are. This time it's up in the power. So here, the shift is up here. And we can see that that's going to be my horizontal shift. And it's backwards of what you think. You would think that it's -2, so it will be to the left, but we're actually shifting it 2 units to the right. This time when it's the horizontal shift, my asymptote is not going to move. So again, I'm going to graph the y = 3 to the x first, -1, 0, 1. So this is 3 to the -1, which is 1/3, 3 to the 0, which is 1, 3 to the first, which is 3. I'm going to graph these 3 ordered pairs, and then I'm going to move them all 2 units to the right. So once I graph my asymptote first, And then my order pairs here. And let me do it in red so it matches. And then here's that one. Let it skim. Now, if you don't want to connect the dots and just leave the dots and then shift them, you can do that. So I'm doing 2 units to the right. So right here, and right here. And then it'll skim right along that same asymptote because I'm not shifting the asymptote when my transformation is left and right. Do a couple more examples and then we'll be done. So again, let's describe the transformation first. Same as the other one. It's up here in the exponent. So again, backwards of what we think. So we would be thinking we would be going left because it's minus, but we're actually going to shift it 2 units to the right on this one as well. So let me quick get some order pairs for 4 to the x power. So plug in same thing, -1, 4 to the -1 is just 1/4. 4 to the 0 is 1, and then 4 to the first is 4. So nice, easy order pairs, and then I'm going to shift them all 2 units to the right. So asymptote, new order, the original order pairs, and now take them all and move them all 2 to the right. So a new one there, here, and here. And then you can connect the points. So again, if you don't want to connect the originals, just put in the points and then you can shift them. You can do that. The asymptote stayed the same since we didn't move it up or down. Now let's do a shift up and down. Same basic function here, so I'm going to use the same table for the 4 to the x on this one. But now the +3 tells me I'm going to go up 3 units. And on this one, my asymptote has to move up. Let me do the originals. So the original asymptote is here. And my original 3 points are here. Here, the 0, 1, and then the 1, 4. I'm not going to connect them, I'll just put them there. And then I'm going to move my asymptote up. So I'll do that now in red. I'm going to move it up 3 units. So it's now here. My new asymptote is located at y equals 3. And now I'm going to take all of those blue dots and move them all up 3. So this one, 1, 2, 3, the one on the y-axis, and then the one that's close to the x-axis, right there. Connect them, and it zooms along that asymptote. Two more graphs, same stuff, and then we're done. And again, I will continue with these notes on Monday, but you do have a WebAssign assignment. It's pretty straightforward. Okay, so the last 2 examples, again, let's identify these shifts. So it's up here in the exponent, and we also have something that's being shifted down because it's the -3. So let's go ahead here. And so this is my vertical translation. So we're going down 3 units, or you can say translating it vertically. And because this is up in the power, this is going to be a reflection across the y-axis. So let's go ahead and try it. Again, I'm going to just do the basic. What I could do here is I could plug in to the 4 to the -x and then just shift all the points. You could do the reflection. It's totally up to you. I'll go ahead and plug it in to this one. So again, if I plug in -1, 4 to the -1 gives me 4. And then when I plug in 0, anything to the 0 power is 1. And then when I plug in positive 1, it becomes 1/4. So again, let me graph. -1, +4, 0, 1, and then the 1/4. And now I can take all of these and shift them down. Now my original asymptote was right here. I now need to shift the asymptote down as well. So 1, 2, 3, and it's now right here. So it's now at y equals -3. And now let me shift all my points down as well. 1, 2, 3. And same thing here, 1, 2, 3. And again, it's going to skim along. It's not going to cross it. Skim along that blue asymptote. Let's do one more with an E. And again, added here. This is going to be, again, a vertical translation 2 units up. And up here, we're subtracting within the power here. So this is going to be backwards of what we think. So it's going to be right, horizontally, 1 unit. So again, remember E is 2.71. So we could do just the x values here of e to the x, and then we could do the shifts. So if we plug in -1, again, remember it's approximately 1/3. And then here, if we plug in 0, it's 1. If we plug in 1, it's 2.71. So I'm going to graph these, and then I'm going to shift them up and right. So here, and then almost to the 3. So this would be the original. And now I can take them all and shift them 2 up and 3 right. If you want to do it in 2 steps, you can. Remember, your asymptote moves. So here's my new asymptote. Okay, so let's go ahead and take all these points. We're going to take them up 2 and 1 to the right. So if I take each one individually, so let's say I take this one first, right here, and I take it up 2 and 1 to the right. And then same thing here, take this order pair of 0, 1, up 2 and 1 to the right. And then the same thing here, up 2 and 1 to the right. And again, do your little sweep right along that asymptote. Again, use the asymptote. It should not cross that asymptote. So my newly shifted asymptote now is here at y equals 2. So we'll continue on with this same set of notes on Monday. Again, we're going to break it apart into several days. But your homework for this part of it is the 5.1a, and it's on WebAssign.